Why carbon forms covalent bond? To answer this question, let us first learn about the carbon atom. Now you know every atom has got three particles, the protons, electrons and the neutrons. When it comes to carbon atom, it has 6 electrons, 6 protons and 6 neutrons. Now the protons and the neutrons are in the nucleus, as you can see in the picture. However, the electrons are in the orbits around the atom. And these electrons are arranged in a specific way. We have the K shell and we have the L shell. 2 electrons are in the K shell and the 4 electrons are in the L shell. So this is the first shell, it's called the K shell, and we have seen it has got 2 electrons. And then the next shell is the L shell, and it has got 4 electrons in it. So the total becomes 6 electrons. However, the carbon atom is not stable. In order to be stable, the outermost shell should have 8 electrons. To make its outermost orbit stable, carbon has got 2 options. It could lose the 4 electrons, or it could gain 4 electrons. Now let us see what happens if it were to gain 4 electrons. So here, if it were to gain 4 electrons, this were the earlier electrons, and it would gain another 4. 1, 2, 3, 4. So the number of the neutrons remain the same, that is 6. The protons also remain the same, it is a 6. But now the electrons have become the 4, or the earlier ones plus another 4, which means there would be now 8 electrons in the outer shell plus the 2 electrons in the inner shell. Total, you'll have 10 electrons. Now the 6 protons inside the nucleus find it very difficult to hold on to 10 electrons. So we have 6 protons which are positive. And why do the electrons remain revolving around the nucleus? Because there is always a force of attraction. These electrons are attracted towards the nucleus. The electrons are negatively charged while the nucleus is positively charged, and these electrons have got to hold on to the nucleus. Here, however, we have now 6 protons trying to hold on to 10 electrons. The number of protons are too small, the number of electrons are too large, and the atom would be highly unstable. So the carbon atom cannot gain stability by gaining 4 electrons. So since now it cannot gain 4 electrons to make the outermost orbit stable, the only next option is left to lose 4 electrons. Now remember, all these electrons are held together to the nucleus by a force of attraction. For each of these electrons to be released or to lose, a large amount of energy is required. So in order to lose 4 electrons, too much of energy is needed. So the carbon atom cannot resort to this method of losing 4 electrons. So the only option it is left is to share the 4 electrons with another atom. It cannot gain 4 electrons, neither can it lose 4 electrons. So the only option left is to share 4 electrons. Let us now see how this carbon atom, this is a carbon atom, would bond with an hydrogen atom. Now an hydrogen atom is made up of 1 proton and 1 electron, each having 1 electron in its outermost orbit. So hydrogen atom has only one shell, that is a K shell, and in the K shell we require only 2 electrons to become stable. So each of these hydrogen atoms require just 1 electron to be stable. So each of these hydrogen atoms will share 1 electron with carbon. 1 electron from hydrogen, 1 electron of carbon, 1 electron of hydrogen, 1 electron of carbon, 1 of carbon, 1 electron of hydrogen. And now if you see, the carbon has 8 electrons in the outermost orbit, while each of the hydrogen has 2 electrons in the outermost orbit. So if I were to draw the structure, I would say there would be carbon here with hydrogen, 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 4 hydrogen, each sharing 2 electrons here, 2 electrons and 2 electrons. So if I were to draw again, I could put a single bond. 2 electrons make a single bond. This is how hydrogen would get a stable structure. This molecule is called methane. This is the formation of the methane or electron dot structure of methane given in your textbook. Now look at carbon. This is the carbon atom, and see the number of electrons it has got. 1 from hydrogen, 1 its own, 1 hydrogen, 1 its own, 1 from hydrogen, 1 its own. So this circle, the inner circle, has got already, the carbon has got 8 electrons. Now take a look at each hydrogen. Look at this hydrogen atom. It has got 2 electrons and hence it is stable. It needs only 2 electrons. This hydrogen has got just 2 electrons and it is stable. This hydrogen has got again just 2 electrons and it is stable. It requires only 2 electrons because it is the first orbit. It's the K orbit. Here also it has got 2 electrons and it is stable. For the carbon, this was carbon, there are 8 electrons, and if you see the electrons here, 1 is of carbon while the other is of hydrogen. Here too, 1 is of carbon and the other is of hydrogen. So 1 of carbon, 1 of hydrogen. Here too, 1 of carbon, 1 of hydrogen. Total will be 8 electrons. Similarly, if you take each of the hydrogen, it has 2 kinds of electrons. 1 of carbon, 1 from hydrogen. If you take this atom of carbon, hydrogen, there are also 2 types of electrons, 1 of carbon and the other of hydrogen. Here too, this carbon has got 2 electrons, 1 of carbon and this one is of hydrogen. So these two, so in this way they share the electrons, 1 of carbon, 1 of hydrogen. So we see that carbon forms covalent bonds. And these covalent bonds are weak bonds. And because they are weak bonds, all carbon compounds have low melting and boiling point. They have low melting and boiling point because these covalent bonds are weak. Here also there is absence of ions. There are no ions here. There is no transfer of electrons. So there is no ions. Because of absence of ions, carbon compounds do not conduct electricity. Do not conduct electricity. In order to conduct electricity, the substance should have ions. And since carbon compounds do not have ions, they do not conduct electricity.